She is a director, UC Berkeley Center for Environmental Research and Children's Health Search. So she has spent more than 30 years examining the effect of environmental exposure on male and female fertility, pregnancy, and children's health and development as a neuropsychologist and epidemiologist. Okay, so Dr. Eskenazi, please.
Thank you very much, and thank you for the invitation as well. It's only appropriate that I'm in Japan, and this is the week that the Minamata Convention starts taking effect, and I'm proud to say that the United States has finally signed on to an international convention on environment. This is the first one and the only one so far. So thank you for doing this. I know it's been quite a history. So I'm going to be talking about the American experience of children's health and the environment. I think that those of us who've been studying children's health and the environment are particularly interested in the first 9 months of life and how it shapes our entire life and what exposures may occur during that period of time. There is a long history of children's environmental health and research on longitudinal birth cohort studies in the United States, not all positive, and so I'm going to go into a little bit of the history. It started in 1959 to 1965. The U.S. Collaborative Perinatal Project, or the CPP, got started. It was enacted in 1951 by Congress to address maternal and infant mortality and cerebral palsy. There were 60,000 pregnancies enrolled, and from 12 university hospitals around the United States. Around the same time, there was a break-off from the Collaborative Perinatal Project for the Child Health and Development Studies. And unlike the Collaborative Perinatal Project, which focused on 12 centers, this focused on one center, the Kaiser Health Plan in Oakland, California, where I'm based. There were 20,000 pregnancies, and 17,000 children were followed to age 5. There were many strengths of these early cohort studies and also some weaknesses. They collected serum samples, maternal and cord, from a large number of participants. They did not collect urine. They also collected placenta, but after 20 years, they had to throw out the 20,000 placentas because there wasn't enough storage space. There were numerous publications, excellent retention, and for subsamples of the cohorts, particularly the child health and development studies, we're up to the 4th generation of follow-up. However, there are key weaknesses of the Collaborative Perinatal Project. It was a convenient sample rather than a sample across the United States. There were only 12 hospitals. It was inefficient and expensive due to the large number of collaborators and inadequate leadership. There was a lack of cooperation amongst institutions and lack of trust, a lack of commitment for the future of the Collaborative Perinatal Project, because these birth cohort studies mean a commitment for a long time to come. They did not collect very critical information like maternal prenatal alcohol, because it wasn't until 1973 that fetal alcohol syndrome was identified, and these studies were begun in the 50s. There was an early failure to produce and publish results, and there was a termination of follow-up in 1976. The child health and development studies, which focused on one institution, had limited generalizability. Again, only sera was collected and the placentas had been discarded. And it's difficult to support the ongoing effort of generations, constant grants to just live cohort to cohort. Both studies tell us about modern day past day exposures, but they don't tell us about modern day exposures, nor about current medical practices or epidemics. In the United States in 2009, we began the National Children's Study, and this was authorized by Congress also, and it proposed to do a nationally representative longitudinal cohort of 100,000 followed from birth to age 21. It aimed to assess the effects of environmental exposures and gene-environmental interactions on a whole host of outcomes, including eventually adult-onset disease. The demise of the U.S. National Children's Study is kind of notorious. There were pilot studies launched in January 2009, and data was collected on only 6,000 families, but it failed. And the question is, why did it fail? Again, poor leadership, inflexible management structure, unrealistic study design. They wanted to enroll people by going door to door. There were escalating costs of data collection and costly decisions. And the NIH eventually stopped data collection in December 2014 because the National Academy of Sciences wrote a report. But by that point, $1 billion had been invested to collect these 6,000. So the ECHO study, which I'm now involved in, was like a phoenix rising from the ashes. It learned from the experiences of the previous U.S. birth cohort studies to study the environmental influences on child health outcomes. It's again coming from NIH, and the money is with congressional approval. The ECHO's program objectives is to improve the health of children and adolescents by both observational as well as intervention research, and to learn how to work collaboratively in team science. ECHO's overarching scientific goal is to answer crucial questions about the effects of a broad range of early environmental influences, not just chemical, on child health and development. There are 4 major outcomes: pre, peri, and postnatal health, upper and lower airway, obesity, and neurodevelopment, and also to look at resiliency, positive health. There are 44 states, including, and also the District of Columbia, Washington, and Puerto Rico, that have enrolled cohorts. They're what they call the IDEA states that provide children living in rural and medically underserved communities the benefits of clinical trials. There are, one single coordinating center, one single data analysis center, and multiple chemical analyses centers. And also one center that's developed new innovative technologies for looking at exposure and health outcomes. The ECHO-wide cohort is a consortium of 84 existing cohorts of mothers and children followed longitudinally to contribute to a single data platform. The idea is to harmonize these 84 different cohorts and also going forward to standardize new measures. The goal is to enroll 50,000 children. A national research resource for use by ECHO investigators, those of us who are directly involved, but eventually, like within a very short period of time, being released to the world for those who ask to use the data. So ECHO has some unique challenges. The idea of unifying 84 disparate cohorts is not trivial. And so one of the first things we have to figure out is how we're going to do that. How we're going to data share and not violate preferred information like medical record information, and how to conduct statistical analyses on the disparate populations. There are also unique challenges for U.S. birth cohorts, some of which do not exist in Japan. For one thing, we have culturally and language and demographic heterogeneity. We are a country of immigrants with many different cultures represented. We believe in protecting the individual, and so sharing data and sharing individual level data is not typical in the United States. The healthcare system, in spite of really trying hard, is not unified and it's not functioning well. So being able to share electronic medical records across state lines, across medical systems, is not well established. We are a widespread geographical area with high mobility of populations. People don't live in the same house for their entire lives. Also, our family structures are not like they are in Japan. It's not with the same fiber of keeping families close together. I'm 3,000 miles from my family of origin, and so are many other people. So the question is, given the complexities of studies like the ECHO study and of the National Children's Study in the United States, are there any advantages to not doing national birth cohort studies, but maybe of looking at smaller birth cohort studies? In one of the critiques of the National Children's Study, Duncan wrote, ensuring adequate representation of our nation's most disadvantaged children in national studies is a formidable task. When you do national birth cohort studies, you tend not to look at in-depth information about high-risk populations. So birth cohort studies focusing on select populations may provide important data on disadvantaged or unique populations that might be washed out when you accumulate across national studies. And that brings me to a study that I've been working on for the last 17 years called the Center for the Health Assessment of Mothers and Children of Salinas, or the Chamacos study. Chamacos means kids in Mexican Spanish. It's a birth cohort study investigating the health of environmental exposures, chemical exposure, in low-income Mexican-American children living in an agricultural community in California. The area they live in is called the Salinas Valley, and it's called the salad bowl of the nation of the United States. It's where most of our salad comes from. Salinas, the main city in the Salinas Valley, is a very interesting city. You don't have to go to another country to leave the United States and be in an international setting. 75% of the people that live in Salinas are Latino, mostly Mexican. 31% are below the poverty level. It has 2.5 times the homicides in the general U.S. average, which is still quite high. 10% of the high school students report being in gangs, and that's report being in gangs, so that's probably an underestimate. So we're talking at a population that's considered to be a very high-risk community for youth gang violence and one of the highest in terms of social adversity. So in 1999-2000, we enrolled 601 pregnant women, certainly not like the 100,000 that are going to be in JECS or the 100,000 that was planned to be in the National Children's Study. But most of these children were from farm worker families. 92% was Spanish-speaking. Most of the mothers were born in Mexico. They had been in the United States for less than 5 years. We didn't ask if they were documented or legally in the United States because we didn't want to know. And now I'm really glad we didn't ask because of U.S. current policy. But we believe that about half of them were not legally in the United States or documented. 96% were living below poverty level. Low education, most either worked in agriculture or someone in their families worked in agriculture. So we're dealing with a very high-risk community that probably wouldn't have been studied in a large national birth cohort study. So Chamacos is a community-based participatory research project. We work very closely with our participants and with their communities. We study the impact of environmental chemicals on farm worker families, growth, neurobehavioral development, respiratory disease, and pubertal onset. We also do very detailed exposure studies, how to measure different chemicals, validation of chemical exposure. We look at mechanistic studies, not just how a particular chemical works on the human body, but also epigenetic and genetic information. And a good part of our research is on community outreach and translation activities. So the Chamacos, as I said, is a longitudinal birth cohort study. We enrolled the women during pregnancy. We followed their children up at 6 months, 1 year, 2 year, 3.5 year, 5 year, 7 year, 9 year, and then every 3/4 of a year after that as they got through puberty, and then at 14 and 16 years. Our children are currently 16 years old. We have collected data on maternal questionnaires every single time. We've done physical exams on the children, very detailed neurodevelopmental assessment, 2 hours of neurodevelopmental assessment at the older ages. We've done thousands of home inspections. We probably know more about the impoverished housing of farm workers than anybody else. We have done lung function tests. We have gone to the teachers to find out about school performance. We examined the children to know what Tanner stage or puberty they were in. We have collected about 250,000 biological and environmental samples of all different kinds: maternal urine, blood, breast milk, teeth, saliva, hair, and house dust. We've collected all these specimens because, in part, we didn't know how to measure pesticides when we started the study. So we had to figure out, well, we better store all of these specimens because hopefully someone will come up with a way of measuring some of these short-term exposures sometime in the future. As I said earlier, our population has suffered through a lot of adversity. 62% are at or below the poverty level, 30% have rodents in the home, low education. They live in census tracts or areas, neighborhoods that are also in poverty, and where there's a high rate of people who didn't complete secondary school. We also have high rates of food insecurity in our population. 36% are food insecure with hunger. Maternal depression is high. Biological fathers are often absent. They have had a lot of mobility and a lot of stressful life events, including deportation. The chemical exposures we've looked at include all of those on this list, but the only one that I'm going to go into any detail on are the organophosphates. So organophosphates are acute neurotoxicants. They depress acetylcholinesterase, causing the central nervous system overexcitation. They are widely used in homes in the United States before 2000, but they were removed from home use. But nevertheless, they continue to be used in agriculture. They account for about 35% of all insecticides used in the United States. They're a little tricky because they degrade quickly in the environment and quickly in the body, so it makes it hard to be able to come up with a good biological measure of exposure. They are excreted in urine as something called dialkyl phosphate metabolites, or DAPs, and that is what we use to measure the prenatal exposure. During the time that we did our study, there were about 500,000 pounds of organophosphates used annually during the year. And we measured those DAPs in the urine samples from the mothers during pregnancy. We showed that those DAPs collected in the mothers during pregnancy were related to the OP pesticides in the house dust and also in the breast milk. So we developed a method with CDC of measuring the organophosphates in breast milk. We have shown that Trimacos participants' OP metabolites, or the DAPs, are high compared to the US. You can see in the blue the Trimacos population, and in the red the National Health and Nutrition Examination Survey, which is the general US population. And you can see that our levels are higher for the mothers as well as for the children. We have shown that the mom's DAPs during pregnancy are associated with shortened gestation, abnormal neonatal reflexes, decreased mental development in toddlers, poorer verbal abilities in preschool, pervasive developmental disorder, which are autism-like behaviors, attention problems in school age, and we have also shown that DAPs are related to decreased IQ scores at 7 years. So what you see before you is the full-scale IQ here on this side, full-scale IQ, and that's comprised of these different measures. Here's the no effect line, and so every single measure is significantly below the no effect line. So with every 10-fold increase in maternal DAPs during pregnancy, it's on a log scale, we see between a 4 and 6 point drop in different components of the full-scale IQ. Oops. We have also begun to look at the DAPs in relationship to asthma, but here we're seeing a slightly different picture. The OP pesticide exposure has been associated in workers with respiratory distress, and it makes some sense because there's innervation by the parasympathetic nervous system for control of the lung tissue. We have recently shown that postnatal, not prenatal, DAP exposure to the child is associated with decreased spirometry and with increased respiratory symptoms in the children. And the DAPs degrade into two different types, diethyls and dimethyls. Diethyls would be, for example, chlorpyrifos, whereas dimethyls would be like malathion or oxydemeton methyl. And we're seeing both of them are associated with decreased lung function. So neurodevelopment has been associated with prenatal exposure, whereas lung function has been associated with postnatal exposure. We also look to see whether there are some children that are more susceptible to organophosphates. Peroxidase enzyme detoxifies OPs in the body, and the amount and efficiency of the enzymes depend on the genes called the PON1 genes. And so we looked at the PON1 genes and the enzyme activity associated with them in the mothers and the children. And we showed that indeed those children that have different polymorphisms, different alleles, have different amount of enzyme activity. So if you're fortunate and you have the RR PON1 gene 192, you have more enzyme activity and therefore may be more efficient at breaking down the organophosphates. We also showed that if you look at the enzyme activity of 6-month-olds, 2-year-olds, 7-year-olds, and compare that to adults, that it's not until around age 7 that children have adult level of enzyme, which means that the level and efficiency of enzyme depends on your genetics and also your age, which means that children up until the age of 7 do not have the same ability to detoxify organophosphates. So therefore, there are some people that appear to be more susceptible, especially young children. Going back to the slide I showed earlier, and let's just look at the full-scale IQ. So for every 10-fold increase in the DAPs during pregnancy, we see about a 5-point drop overall. Now, what if you looked at the mother's enzyme, PON1 enzyme activity, and you categorize the women into low enzyme activity, meaning less efficient, being able to detoxify organophosphates, moderate levels, and high levels? If you see a 5-point drop for every 10-fold increase overall, if the mother has low levels of enzyme, you now see a 10-point decrease in IQ. So with every 10-fold increase in mother's DAPs during pregnancy, those mothers that are less efficient have a 10-point decrease in their child's IQ. If the mothers were moderate in terms of their enzyme activity, those children had only a 5-point decrease in IQ. And if you were lucky to have high enzyme activity, you had no effect on your children. So it's not just the exposure, but it's also the genetics. We have also begun to look at interaction between adversity and DAPs. So not just enzyme activity and genetics, but also all the adversity that we've been talking about. And what we see is that children that have higher lifetime adversity, social adversity, are those children who seem to be more affected by in utero exposure to DAPs. So we see an interaction of social adversity and DAPs. And different kinds of adversity interact for boys and for girls. So what happens when you take a neurotoxic exposome and you mix it with stress and you mix it with neurobiology and genes? Are we going to see in the future that high level of adversity and juvenile delinquency and gang violence? Is this contributing, this interaction all contributing to what we're already seeing in Salinas? Our work on this small birth cohort has greatly informed regulators. We have seen over the years that if we started in 1999-2000, a sharp decrease in the amount of organophosphates that have been used in California. It's the red. Our work has also helped to develop new exposure science. We worked with Manisha Arora now at Mount Sinai to develop a method to be able to look at metals in teeth. We have developed educational programs for the entire community. For the very young, we've developed puppet shows about pesticide exposure. For the pregnant women, we have a kiosk. We have tapped into almost every community group and have educated about 60,000 workers all over the Salinas area and now across the state of California. We will continue to follow Chumacos into adulthood. We have funding now to look at the children up until age 21. So many lessons have been learned. I'm going to leave this for the discussion, but I will just pass through this, and this is very important for JECs, and we'll talk about this later. Our experience, our protocols have advised many birth cohorts around the world, and so we hope to be able to do that here in Japan as well. For more information, please look at ECHO, and please look at Chumacos, and we're looking for a postdoc, so if anybody knows anybody, we're hiring. Thanks to our funders and IEHS primarily and the US EPA, and to all of the scientists that have been involved in Chumacos since the inception of the study, and thank you.
Okay, thank you very much, Dr. Eskenazi. Okay, so now way floor is now open for discussion. The person who has a question, please go to the microphone and introduce yourself before question. So, are there any questions? Okay, go ahead.
Hello. Hello, this is Lorenzo Chiardi from Italy. I have a curiosity to ask. What were you saying to the mothers, to the families of a Chamaco study of children with very high levels of exposure to organophosphates?
That's a very important question. And you also may be tapping into the fact that if you intervene, you're actually affecting your study during the course of doing the study. But we made an early decision that we were going to inform our population right off the results of their actual individual level results. So we give back the individual level of exposure. And we also give back incredibly large amounts of information about how they can reduce their exposure. We also work with the policymakers and the growers to inform them of the results of our study with the hope that they will reduce exposure to the populations. And hopefully our study has worked in that way. Did I answer your question? So we are very truthful.
Okay, another question? Okay, go ahead.
I'm Reiji Kojima from Yamanashi University, Japan. My question is regarding teeth. In your cohort, you collect the teeth. My question is, how do you analyze teeth, and what is the goal or the purpose to find out from the teeth?
So we did not analyze the teeth. Probably the best person to speak to is Manish Arora. He's one of the rare environmental dentists in the world. But the reason why we collected the teeth was actually not to look at chemical exposure. We were going to look at cortisol in them. We just happened to have hundreds of teeth. It was very important to have the same tooth, so the incisor. We couldn't readily look at different teeth because they all develop embryologically at different times, slightly different times. And what Manish is able to do is he can recreate by gestational week. For example, we looked at manganese. The manganese measure in the tooth like the rings of a tree. And so unlike dissolving the entire tooth where you just get one single measure, you get a measure by gestational period in the tooth. You can look at the papers and speak to Manish about the method. He's the environmental chemist that worked on it.
Thank you.
Any question? Is that okay? Oh, one more.
Thank you very much for a very informative presentation. I'm from one of the 15 regional centers of the JECs, and my question is from the project management point of view. So you have been successfully following the participants up until like 16 years already, and if you could just give us some tips to keep them within the cohort, because like not like Scandinavian countries, like they can follow the PIN number, the personal identification numbers. Like we are in the same situation as you are, And maybe in your area it's not as mobile, like people are not as mobile, like you mentioned for the
Very
most of the
mobile.
American people. But what is the incentive for the participants, and then how you can kind of keep in touch with them? And
Our population is extremely mobile. In fact, it's called a mobile farm worker population. And we lost a lot of our cohort in the first 6 months because we weren't smart. And the way we got smart is we found this person on our team who was like a detective. And she has stayed with us for 16 years. If we lose her, we probably lose our cohort. She knows everybody personally.
Okay.
We've become almost like a social service institution. When people run out of food, when they lose housing, when their husband beats them, they come to her. They trust her. When they're concerned about losing, being deported, they come to her.
Okay.
And so she has provided a service that's over and beyond the study. But the other thing that we've learned is that you must get the phone number of the grandmother.
Okay.
And in our case, the grandmother is almost always in Mexico.
Right.
But it won't be the case, hopefully, in Japan.
Right.
But the grandmother always knows where her daughter is.
Okay. Thank you very much. So it's always, it's not something mechanical or system-wise, but it's more like the people or the human resources.
It's the human contact and the
right.
fact that we are trusted. It's very important for them to be seen not as objects, but as people.
Right.
And the fact that we gave back, to answer the other person's question, that we gave back the data and we also told them what we really could or could not know from those data was essential for them to trust us.
Right. So it's more like reciprocal communication.
It was a reciprocal communication. We created a community council because there's no real leadership in the community. There's no unifying group. And on the community council are farm workers as well as growers. They don't usually talk to each other. We've also had people suing each other at the time that we had our community meetings, and we would sit in between them. But you know, just the fact that we have the respect of both the growers and the farm workers
Right.
and the women in our study really takes time and honesty.
Okay. All right. Thank you very much.
Okay, thank you. So I'm afraid time is up. Okay, thank you very much, Dr. Eskenazi.